In this video, we're looking at the indefinite integral of x squared cosine pi x cubed, and we're going to take two different approaches to this integral. The first approach is what I could call the informal approach. In other words, we're just trying to see how the chain rule works backwards, and then we'll follow that up with what I call the formal approach, where we use an explicit u-substitution. So for the informal approach, all we're trying to do is see the derivative of the interior function in the integrand, and that takes care of the chain rule. So here's what I mean. I see an x squared in that integrand, but I see the derivative of the interior is 3 pi x squared. So I'm just going to put the 3 pi in there and write 3 pi x squared and cosine pi x cubed dx. And of course, you can't just throw a factor of 3 pi in there without adjusting for it in front. So I'm going to put a 1 over 3 pi in front. And because constant multiples are free to move in and out of integrals, this is a legal move because the 3 pi and the 1 over 3 pi cancel each other out. So now we have the derivative of the interior function sitting in this integral, and I can see quickly what I need to differentiate to get this integrand. In other words, the antiderivative. The 3 pi x squared takes care of the consequences of the chain rule, and all I have to do is think to myself, what's the antiderivative of the cosine function? And that's the sine function. Don't forget to put a plus c on that, and we're done with the informal approach. Now, I highly encourage my students to take this approach to most integrals. This is how you really do it when you move on to using calculus in other subjects like physics, for example. But if it makes you nervous, if it just feels a little bit too loose, you can always check your answer by taking the derivative. And this actually just makes you better at guessing derivatives backwards anyway. So let's take the derivative of this thing. I know the derivative of the plus c is 0, so I'm not concerned with that. When I take the derivative, the 1 over 3 pi is a spectator. Then I need the derivative of the sine of pi x cubed. Well, I start by taking the derivative with respect to its argument of pi x cubed. In other words, I treat the pi x cubed like a single variable. And then the chain rule says I have to multiply by the derivative of that argument, which is 3 pi x squared. The 3 pi's cancel out, and I end up with x squared cosine pi x cubed, the integrand I originally started with, so I know my antiderivative is correct. Now, in the formal approach or explicit u-substitution approach to this integral, we're really doing the same thing. We're just identifying the inner function as a u, and then we're looking for du somewhere in the integrand. So I'll start by saying let u equal pi x cubed. Now, you do have to be looking ahead in order to have any confidence that this is going to work. So you should be looking ahead to see that the derivative of u is somewhere there in the integrand, at least the variable parts of it. The constants we can always move around. So next I get the differential of u, that's the derivative with respect to x, so 3 pi x squared multiplied by dx. And this is good because I see an x squared in the integrand, so I have the right variable pieces in there. Now, one way to handle the integral transformation is to go ahead and explicitly solve for dx. I can replace dx with a du over 3 pi x squared. And then we're ready to transform this integral. So I have an x squared and then cosine pi x cubed. Well, that's just u now. And then dx, I wrote as du over 3 pi x squared. And the x squareds cancel out. Again, that's not going to happen unless you have the derivative of u essentially sitting inside this integral. So you need to be looking for that ahead of time. I can pull the 1 over 3 pi out in front. And then I just have the integral of cosine u du, which gives me a sine u. So I have 1 over 3 pi sine of u plus c. And you're not done until you express this antiderivative in terms of x. So I have to go back and replace u with pi x cubed. And I get 1 over 3 pi sine pi x cubed plus an arbitrary constant c. And we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left. Or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.